Right, so morning everyone. Today we are going to be looking at the process of boiling, so the change of state that's there. So the first and most important thing is that you will be able to define the term boiling point, and so what happens at boiling point, and you will need to be able to use the particle model to describe what's happening to particle behaviour at those points. We'll do some data processing, so some calculation of means, and then we will also have a go at plotting a graph to see what happens. And then using that graph, we should be able to identify the point at which a substance boils. And then a final little activity is trying to see whether we can use information on boiling points and melting points to an extent in order to be able to predict the state of a substance at different temperatures. So, first thing that we want to think about is, well, what do you know by the term boiling? So just pause this and have a think about that. On these images, we can see boiling happening. So we can see that there are these bubbles contained within the water that is being boiled here. And then we can also see this gas or vapour, in the case of this as it's water, being given off. So when we're talking about boiling, we're talking about when a substance is changing state from a liquid to a gas. Now, when I interviewed to do my teacher training course, one of the questions that they asked us was, well, what's inside the bubbles when the water boils? So have a go and see if you can answer that question. Now, the reason that they answered that question is because there are common misconceptions about what is actually in those bubbles. A very common answer is that they contain air. They do not contain air, because where does the air come from? What they, of course, contain is water gas. So the gas form of the water, so steam or water vapour. It's where some of the water is boiled, it's changed state from a liquid to a gas, and so then it's contained within those bubbles. So that's a common one that they ask in order to see about whether you hold that kind of common misconception. So summary wise, we want to think about what boiling point is. So you need to write down this definition. The boiling point is the temperature at which a substance changes from a liquid into a gas. So my first question would therefore be, what's the boiling point of pure water? And so, of course, as we can see from the image over here, the boiling point for pure water would be 100 degrees C. So my follow-up question, let's not worry about the 100 degrees C here. What state is water going to be at 150 and 25 degrees C? So have a think about that. So hopefully you should identify that 150 degrees C we're above the boiling point, so the water will be a gas, whereas at 25 degrees C we're below the boiling point, so the substance is not a gas, but we know that water melts and freezes at 0 degrees C, so this is above that, so therefore our substance should be a liquid. So we want to think a little bit more about what's actually happening to particles as these substances change from a liquid to a gas. So at the bottom here, we've got a representation of our liquid water, and so we can see the particles are really close together. They're all kind of jumbled around, there's a random order, but the really key thing is that these particles are touching. So this means that liquid water is incompressible. We can't squash it, which is the basis of hydraulics. Now, as we heat this substance up, so we can imagine that there'll be some heat being applied down the bottom here, some of the water particles gain enough energy to turn into a gas. And so what that means is now that we can see that these particles are spread out, they're no longer touching. And what we can also see is that these particles are moving around freely. So they can't just move, kind of jumble past one another, they're able to move in all directions. And we can see that represented in the diagram, moving in all directions randomly. Now, the reason that they can do that is because their particles have gained heat energy, thermal energy from the heat that we've been applying to it, which means that they are able to move faster. If they move faster, we say that they've got more kinetic energy, and so that means that the particles have got enough energy to overcome the bonds that are holding them all together, and so they spread out, they move freely, randomly and quickly in all directions. So make sure you copy down the notes on this slide, please, and a quick version of that diagram. Please do not try to do it to that degree or have a go at printing off this diagram. It's a really important one to understand about how the arrangement of those particles changes. Right, so now we're going to refer to the worksheet. So this is a data table showing the temperatures for 3 glasses of water and beakers of water, and what we're looking at is that we're heating them up, and so over the course of 9 minutes this is what happens to the temperatures. Now the first thing that I want you to do is to calculate the mean, finish off calculating this mean column for me. So in order to calculate this mean, I've taken 23, I've added it to 22, I've added it to 24, and then I found out the total, so what that equals, which is 69, and then I've divided that by 3 in order to give me a mean value. Now you need to do that for all of these values here. Wise, you can check your answers against all of these, and then your next job is to plot a graph showing what happens to the temperature as the time goes on. So some things that you need to be considering: what type of graph should we be drawing, what's going to go on each axis, what's the maximum number to go on each axis, what's the scale, we need to label each axis, and we need to plot the points from the table. So just consider that for a moment and then I'll run through it. Okay, so we're going to be drawing a line graph. And so on the y-axis, and the y-axis is the vertical axis, we're going to have the mean temperature. On the x-axis, we're going to have the time. So the maximum number time-wise, we should be going up to 9 or 10. We shouldn't be going too far, so we'd probably go up in ones. And on the temperature, we need to go up to 115, 120. So we're probably going to go up in 5s or 10s. It needs to be regular. We need to make sure that we've got our totals and units on our axis, and we need to plot our graph. If you need a little bit more help, then there's some axes on in the next bit. So this is what your axes should look like. We've got time on the x-axis, x is across, and y is up, y is up. So temperature is on the y-axis. We've got headings, we've got units, we're going up in regular divisions, and then we're going to be able to plot our data. So plot your graph now, please. And then you need to have a go at the questions on that sheet, please. So marking your graph, you'd want to be checking that you've got your axes the right way around, as was shown in the previous image. You'll get a mark for titles, a mark for units, you get a mark for correct scales. So the graph should be over half the page, it should go up to 120, it should go up to 10. You need to get correct plotting, so perhaps someone at home could check your plotting of your points for you, and then you get 1 mark for the line that you draw on. Now the line's a little bit more complicated, so I'm going to show you what that line should look like. So it should look something like this. So we have a point where the graph is sloping upwards. We then have a point where the graph has got no slope, where it's flat, where there's no gradient, and then the graph slopes upwards again. So here's some considerations for you. What point on your graph do you think represents the boiling point? Now, we already know what the boiling point is, so you should be able to notice that from the graph. And therefore, that will tell you about how we can identify the boiling point of a substance from its graph. So just pause and answer those questions. So hopefully you should be identifying the fact that the boiling point is of course 100 degrees C, and it's the point on the graph where the graph is flat. Okay, so a flat point on a graph indicates that a substance is changing state, and so in this case it's a liquid in this first part of the graph, it's a gas in the second part of the graph, and here it's changing state from a liquid to a gas. We can consider this a little bit more. So here in the liquid state we can see that the temperature is increasing, so the particles are gaining energy, and so they end up moving faster, but they're still in contact with one another. Once we reach 100 degrees C, this flat point of the graph, the particles are going to split apart from one another. The bonds that are holding those particles together are going to break, and so all the energy is going to be going into this process of breaking the bonds and separating the particles. So the temperature of the substance doesn't increase anymore. After that point, however, the particles gaining more and more energy, therefore they're going to move much faster. Their kinetic energy is increasing, and so the temperature begins to increase again. So answers wise for your worksheet, in order to just be checking those off, please. So 3 questions for you to consider now. So pause video, have a go at these 3. So question 1, substances in the bubbles in boiling water should be steam or water vapour that you could be identifying there, or water gas. What is meant by the term boiling point? It's temperature at which a substance boils. Now this one's an interesting one, it's a little bit more complicated. So predict the state of silver at 1000 degrees C. So its melting point is 961 and the boiling point is 2210. So 1000 is above 961, so the substance has melted, but it's not above its boiling point, so the substance will be in a liquid state. Final activity is to try and put these statements into the correct order. So pause video, have a look at that. So the first one should be about the fact that water particles are able to move past one another freely. Then, as we heat up the water, the temperature is going to increase, which means that the water particles are going to gain energy. Then, after we've heated for a period of time, we'll see that the temperature of water will reach 100 degrees C, which means that some of the water particles are going to have enough energy to leave the rest of the water particles, and so those particles are going to turn into a gaseous state, and so we would now call them steam or water vapour particles, and they are going to be able to move around freely. Right, thanks a lot. If you've got any questions, and send them to me on Show My Homework. Hopefully you'll have worked through your mark, and remember to send me a picture of your graph and your worksheets, please. Thank you very much.